Hi there, welcome to Madness Code. So in this video, we are going to see about K-means clustering algorithm. So before we get into K-means algorithm, we must know what is clustering. Okay, so clustering is nothing but identify the pattern in a data items. After identify data, we need to make a group them based upon the common attributes. So each data have some attributes. So we need to identify the common items and then we are going to make it in a separate group for each data. So each data we need to collide into that group and make it as a cluster. So that is nothing but a clustering. Okay. So we are going to achieve this clustering by using K-means clustering algorithm. Okay. Next slide, we'll see about what is K-means and what are the points which we need to remember for K-means clustering. Okay, sorry. Okay. So K-means clustering is the unsupervised machine learning. So I hope you all know about the difference between supervised machine learning and unsupervised machine learning. So supervised machine learning, which means we need labels to predict the data. For unsupervised machine learning, we don't need to any labels because we have only data or features. By using the data, we going to group the clustering, identify the pattern, and make it as a group. Okay, as I said, the second point, you see there will be no labels, and third point indicates K. So if you have data, first um, you have to come up with a K value. So K by how to identify? There are a number of methods out there to identify the K values. Mostly, we need to pick the random number. If we know the group of this data items, then you can keep it those number as a K value. For an example, if you make a K value as 3, see in this case, the 3 centroid value will going to create in this algorithm. So what happened? One, the centroid value will get created, and for each iteration the model will check the closest data between the centroids and it will assign as a group. So the iteration will continue until the distance of centroid is minimum. I hope it's very clear now. This is the common point which you need to remember when it comes to k-means clustering algorithm. So next slide we'll go see about what are the use cases or that when we're going to use the k-means clustering algorithm. The first case you can see identify the photos of a specific integer. Suppose if in a folder if you have multiple photos, so in this case if you're going to make it as a group or you're going to make it as a or need to separate each photos based upon the group. So in this case you can use this k-means clustering algorithm to identify the groups. So that is the first use case. If we come to the second one, by using the latent factor analysis technique, you can find the common drivers. Suppose if you have 200 stocks, each drivers has a different information. So by using that information, we can make it as a cluster. That's called as latent factor analysis. Third one is the clustering. So as I said earlier, the find relevant document in a corpus. Each corpus have multiple documents. If you want to make it a separate group for each document, so in this case, by clustering technique, we can use. Okay. Same thing. Next one is fraud and credit card transaction. So by this transaction, so we can able to predict by using this algorithm. Okay. So this is a general use case. In case if you have more use case, please comment in the session. We can discuss later. Okay. Um, Next we see about how that k-means algorithm, the clustering and the centroids will work. Okay. So if you see here the k-means clustering, this is a group of data. So here if you see there will be no groups, no clusters. Okay. It's a like xy coordinates data. Okay. So now we identified data. We are going to identify 4 clusters. So here the k value will be 4. So if you see here, this 4 star indicates the centroid value. So this model has identified initially this value becomes centroid for this group and this value becomes centered for this group and this value becomes centered for this group. Okay. So the iteration will continue. When it comes to the reiterate the same method again, again that value will change. I mean the centroid value will change, and they will make the group again the different groups. See, we see here now the k value got moved here, and then it will first iteration this data will be in the first group, but in the second iteration, so it will make these data as in a in this group. So that is how that iteration, the iteration will make the data movement, and finally stop to find the closest minimum distance between the centroid and the value. Okay, that there will stop this value and it will give the output to us. Okay, this is how the k-means clustering algorithm will work. I don't want to get into the more detail in the formula wise because it is too difficult to understand. So as simple, if you are going to use only this model by using some data, so I think this is more than enough now. Okay, this is a general introduction about the k-means clustering. Maybe we can move on to the code level. Can see how to code by using the Python language, can apply the k-means clustering algorithm. Okay. The next, so okay, see here I use the Jupyter. So if you have any other node, I mean Python, whatever IDE is flexible for you, I mean it's comfortable for you, you can use it. So here I put sklearn. Sklearn is a basic, I mean basic uh, library we use for the sklearn. So I imported here, and the metrics also sklearn has a cluster of k-means, so I imported here, and the Panda NumPy MATLAB, which is used for to plot the graph. This is a random number. If you want to get random number, we need to import this library. Okay, that is, now we have imported all the libraries. Next ones we are going to create data. Okay, by using the data we are going to apply the model. So for that I have created a random data between 1 to 200. If you see here, I am going to get the random integer between 1 to 200. I'm going to apply that two-dimensional array, and I'm going to save this data into data 1. So if you see second, I have taken 200 to 400 random value. Same way is it two-dimensional array, and I'm going to save data in data 2. Same thing I repeated in 400 to 600, and I'm going to save data in data 3. So now I'm going to combine all this data into a single array of data. So if you see here, data 1, data 2, I'm going to append by using numpy, and then again I'm appending the result with the data 3. Finally we got a single data. So if you see here, in this data we have a combination of multiple groups, which is value having 1 to 100, and between 200 to 400, and between value 400 to 600. So now we know there are, can identify the three groups from this data, because we know some value is between 1 to 200, and some value is between 200 to 600, and some value is between 600 to 800. We know that, but our model not, they don't know what type of data which we are going to feed. Okay, now we are going to test this performance. Okay, before we get into the model, as we know, have three uh, groups of data is available in that variable. So we are going to label those data. So we know the first 50 will be as a 0 label, and then second 50 is a second one, and third one is third one. So I am going to append this label into that the same data. For that we need to use the data frame. So it is easy to visualize the data in the data frame. That is the reason I am using here. So you see here data X is we are feeding data into the data frame, and the label, as we know, we have three different labels: 0, 1, 2. I'm feeding here. Okay, the finally if you see the top 10 sample, I'm not top sample, random 10 sample, if you see this is, we have multiple levels: 2, 2, 1, 1, 0, 0. We can keep it this one now, because after we predict the data from our model, we can compare this data with our predict data, so can measure the accuracy. That is the reason I have created here. Okay, next one is we are going to create the k-means clustering. Okay, um, here n cluster denotes k value, and this is called maximum iteration 10,000. We are going to fit that data. This data which we have created earlier. So this is the data. This is the one. So in this data we have a combination of 100 to 200, 200 to 400, 400 to 600 data we have the the two-dimensional array. Okay, or remember, it always supports two-dimensional. If you have one-dimensional, again we need to reshape the model. That is the reason I have created in the two-dimensional array. Okay, now we make the line. Now we are going to run this cell. Okay, okay, that's it. Now the model has predicted the value. Now we are going to see the labels, the K-means clustering algorithm which was predicted. Okay, if you see here, this is one cluster. I think if you plot the graph, I think it would be more clear. I think this is the second cluster and this is the third cluster. If you see here, if you see 0, so somehow it has identified 0 in this cluster. But if you see this one, it will everything as a single cluster, and here if you have another cluster. Okay, now we are going to see the centroid value. Centroid value is nothing but the k value. Initially we said the k value is 3, which means it will create a 3 centroid value. Okay, if you see here, this is centroid value. This is it will denote the first cluster. This one it will denote the second cluster, and this is the one it will denote third cluster. So if you see here, it is range between 200. This is range between 100 to 200. This is range between 400 to 600. Okay, so if you make a plot graph by using a matplot, I think it would be easy to visualize the data. I mean, we should visualize the cluster. Next, we'll see the visualization. Okay, now I am going to use the color. This one, that is a plot figure size, and this is one is the plot scatter. So if you see here, this is the data initially we have given to the model, and this is the result which the K-means model has predicted. Okay, this is the centroid value. So if you run here, okay, if you see here, this is the model has identified as one cluster, and this is the second cluster, and this is the third cluster. If you see here, this is the red mark indicates the centroid value. So centroid, which should always come in the center of the cluster. If you see, this is in center. So initially it may be in here, but after the multiple iteration, the final value came as here, because this value become very closest to all the data. This is how the K-means clustering algorithm will predict the clusters, and it will form the groups. Okay, I hope this video will help you to understand the basic things about the K-means clustering algorithm. So in the next video, we are going to continue the same session, and then we are going to see the multiple performance measures in the K-means cluster algorithm. Also, we are going to see multiple way to tune the model and to get a better result. Okay? So keep watching and subscribe this video and share this video.